The NOAA's Great Lakes benthic mapping program utilizes CVision AI's Tator enterprise software to perform substrate analysis with our drop camera, RV, and AUV footage. We'll do a quick introduction here of the annotation tools CVision developed in collaboration with NOAA. First, recorded videos are transcoded into efficient streaming formats on Tator Cloud and organized by folders, by location, system, and deployments. Corresponding metadata, such as cruise ID, cruise leg, and deployment number are attached. Navigation is then smooth and temporally associated with the video frames. Let's take a look at annotating one of these drop camera videos. Annotators first decide how many samples they want to take around the associated site by creating annotation windows at specified distance intervals. These are highlighted in green because an annotator has already done that for us. Within each window, annotators will select a frame to annotate, and they'll mark it as an annotation frame. And we can use the entity browser to cycle between them. The Dive Map applet displays the navigation path and the existing annotation windows in blue. We can also create new proposed annotation windows and visualize them before saving them, and toggle off different plots and text. So let's annotate a frame by first loading the annotator helper. This is an applet that guides the analysts with completing their substrate, CMEX, and biological classification workflow. We'll begin by creating our database entries. And next, let's calibrate this image using the visible lasers and the image scaling tools applet. This will allow Tator tools to convert pixel length into a physical distance. And now that we've calibrated the image, we have to decide if we want to annotate the substrate using the grid tool or with polygons. Let's demonstrate the polygon method using the Quick Mask applet. This applet uses the segment anything model, hot loaded onto a model server to quickly create polygons. And once we've created our polygons, we'll switch back to our annotator helper. We'll apply the rock mass labels, which will use the physical distance corresponding with grain size to classify these rocks. And then we'll apply a background substrate to fill out the percent cover. We'll then make our CMEX classification and save it. The CMEX classification is automatically calculated based on the substrate percent cover. Let's go ahead and refresh, and now we got the green check mark indicating that we're done annotating this frame. Alternatively, we can classify an image using the grid tool. Let's go ahead and jump to another frame to demonstrate that. First, let's use the filter image applet. We want to try and increase the contrast a little bit to help us annotate this. We'll go ahead and adjust the gamma, and we can apply a white balance filter as well. Now we'll go back to our annotator helper, create our annotation states, and just like before, we'll calibrate. And we can see here that we've already calibrated previously. up the grid. We'll change our dimensions. And we can start filling in the grid as appropriate. Go ahead and save this. We'll go back to our annotator helper. And then we'll take our grid values and apply them to the existing substrate. And these are the values that we used, are calculated based on the image scale applet grid tool. And then we'll categorize our CMX entry. And then we're done. After annotation is complete, QA/QC is conducted, and a formatted workbook can be downloaded for the modeling team to process. On behalf of the folks at CVision, thanks for watching, and feel free to reach out with any questions, and stay tuned for additional updates of the fantastic work conducted by the Great Lakes team.